Hi, this is Dan Smigrod, founder of the Matterport User Group Forum. We're here at the IVRPA conference in Quebec City, and with me is Urs. Urs, tell me about your company and your product.
Right. So we have this new product here.
First, tell me your name.
My name is Urs Krebs. I'm from Switzerland. Our company is called Sites and Photocore, and together we are building a unit which is called FOVEX Metric, which is a photography device which is capturing high-resolution 360 spherical images,
yes,
which we then convert in our software into photogrammetry, into point clouds, and into 3D measurement, 3D networks. So let me quickly explain.
Yes. First, before we talk about how it works, let's talk about what are the applications of why someone would want a point cloud as the final product.
Well, somebody would like a point cloud to reconstruct a building, for example. You go in and you take several images, you build up a 3D network, you create a point cloud, and then in point cloud software or in CAD software we can reconstruct the building very precisely. So that's the whole point.
So if I reconstruct the building and I have it as a point cloud, how does an architect actually use the point cloud to do something with it that wasn't possible before a point cloud was possible?
Before point cloud was possible. Well, before point cloud you would have to use building plans, I would say, or you would have to build anything from scratch from CAD, which is first of all very time consuming and secondly very imprecise.
So the first thing that we replace with this solution for an architect is if there's no as-built, there's no floor plans, then it's possible instead of taking lots of pictures, taking lots of measurements and reconstructing the space, that you solve that problem with a camera that is with a solution that's dedicated to creating a point cloud.
Yeah, that's correct.
In order to give the architect a tool to import into their 3D modeling program using the point cloud.
Yeah, that's
correct. So you talk about architecture. Are there some other industries that the point clouds matter?
We do have a lot of demand from forensic, so from the police. They want to document the crime scene, and they are time constrained, so they want to go in fast, take a couple of pictures, and then back in the office they want to process those images, and sometimes they don't know exactly what the points of interest are, so they really want to document the whole scene first, and then take it back and then process it.
So that's forensics. You talked about for an architect. Are there maybe three other industries that
there is
use
the movie industry, like the VFX industries who want to
special effects in the movie industry.
They want to recreate certain scenes, maybe certain famous scenes, right? And where you're not allowed to film, so you want to recreate this in 3D to be able to use this later in the film. There is a community called in CGI as well, computer-generated imaging. So anything that has to do with products, build products in 3D. You also need to have photorealistic backgrounds for that, so that's another one.
So in the case of film and television for special effects, if you want to do a scene here, but you're not allowed to film here, but you could come in and quickly create the point cloud, then you could go recreate that location someplace else as a set.
That's correct.
That's correct.
That's correct.
And I'm sorry, I think there was another use case or application.
Well, there are a lot of engineering in general.
Engineering.
When you want to measure certain constructions and document them and share them with a team of engineers, for example. That's another.
Okay, so that's great. I think we talked about movie, film industry for special effects, architects for engineers, forensics. So that's kind of an overview of use case for point clouds. Now, with your device, how do you actually do that?
So with this device,
and this is called
it's called FOVEX Metric. So
FOVEX
F-O-V-E-X.
FOVEX Metric.
FOVEX.
Okay.
So what we do with this device is it's a DSLR camera, high quality, full frame, with a 20mm lens. So we do it the traditional way. So we create a sphere with this camera. The metric is working automatically. It automatically measures the light. It controls the camera. It creates the exposures. And we finally get a 230 million pixel sphere, which is perfectly stitched.
230 million
Spheres.
Pixels of a sphere.
Yes.
So does the camera stay in one location only, or does the camera move around the space?
So we create several images. Typically, one from this point, I would then elevate the camera by maybe 30 centimeters,
Yes.
1 foot, do another one, and then go to several other stations to have a certain, let's say, intersection angle to our objects, because we need this for the next step, which is then happening for the photogrammetry. So we need to create several.
All right, so you went a little bit fast for you, so let me see, understand. So the camera would typically rotate 6 times around?
Well,
or
we
3
create
times?
15 images. Okay?
15 images
15
around,
yes.
and then it's rotating how many degrees to begin the next set of images?
Well, no, the next set of images, I would simply elevate this now to an exposition, just go up.
So that's all we need.
That's all we need.
15 images.
15 images.
And this is just a digital camera. This is does it matter which camera?
This is a Nikon camera.
Does it come with the Nikon, or
It comes as a complete set.
complete
yes.
set? Everything you need
Everything
out of the
together.
box.
Yes.
Okay, great.
So I would create my second set of images here,
Yes.
and that's it.
And so, for a space this size, for example, let's say we didn't have floor plans for this lobby.
Well, if you want to have no occlusions, you would have
Yes.
to, I would say, create at least 10 stations.
Yeah, so an occlusion would be, help me out, so if I take this and this,
Yeah.
I'm going to have maybe some spot where I'm missing data, mostly related to tables. So if I really wanted to capture all the data around the spot that the camera can't see, I have to keep moving the camera to find those places in order to complete to capture the images that will be used to create this. All right, so now we've just done this entire space, and we didn't have to do anything other than hit the button, have it go on autopilot, move it at various heights, move it around. How many different images would you might have for this space here or in that camera part?
So basically, I just place my camera in the different spots where I need. I don't worry about the data at all. I just save it to the camera.
Yes.
Once I'm done, I copy everything on my computer.
Okay.
The software will sort out the images in different groups and different objects.
Yes.
And then it's automatically stitched. The stitching.
Is this something to show us here? And maybe what we could do here even is to say, let's see what a point cloud looks like even before we go to look at what the steps are.
So, we've got a point cloud here. Maybe just show it on the big screen.
Yeah.
It's easier.
So we're looking at a point cloud here. Interesting that it's in color. Do you want to comment about that it's in color?
Exactly. So the big difference is we get this point cloud directly from the colored image.
Yeah.
So this is one of the big advantages of the system. You get a color point cloud directly.
I haven't seen a color point cloud before. So is this unique to your solution?
You can create point clouds from images with other software as well and with other devices, but the difference is we create it because we have a calibrated system, we have a certain claim on the accuracy of the point cloud. So our accuracy is 1 centimeter in 10 meters.
Yeah, so your accuracy, excuse me, let me just make sure I got that. Your accuracy is 1 centimeter per meter.
No, per 10 meters.
Per 10 meters.
Per 10 meters, yes.
1 centimeter per 10 meters
On
for
average.
accuracy. And does the color help me understand the space? Just simply
Absolutely.
that I see orange and white, does that actually tell me
Yes,
something?
absolutely. So I can very easily orient myself in the point cloud. I can zoom in. It's very easy to. I know now this is my wooden door back here.
Yes.
So it's easy for me to understand that. So I can go in here. I did a little measurement here. I can directly
Okay,
measure.
and just to be clear, you scanned the space, but you only did it as a demo. So there's normally we would see a point cloud, and it would be almost all filled in.
Yes, exactly. So this is just a very rough one.
A
with
rough
two-
one for the purpose of today's demo.
I had two customers here. We did 2 images, one on top of each other, and we created this in maybe 20 minutes.
So even if we're looking at this, but this is not really a fair representation of the quality, the caliber of the work, because we only have done a couple of rotations of the camera to create. So did you want to show how is this? You import the images is you hit the button and then it does some kind of stitching and then it's a conversion process?
Exactly. So the first step is back to this. So the first step is to create images. That's done with what we call FOVEX Monomaker.
With FOVEX.
FOVEX. F-O-V-E-X.
FOVEX Monomaker.
Yeah. So basically we define the input folder, the output folder, and it will automatically stitch the images. You can see the images here. And this will be an output to
so it's actually taking regular pictures just like we would expect the DSLR camera to create in order to begin this process.
And we end up with this.
So we have regular photography.
Beautiful spherical panorama. It's actually, because of the calibration, it's geometrically perfect. So 3D purposes, this is a very good raw material to use after.
Yes.
So and you will not find any stitching errors.
So you actually have two uses here. Not only if your end game was to have the point cloud, the side benefit is you get a perfect 360 degrees sphere.
Exactly. Yes. Exactly.
A little bit of cleanup for the tripod.
Yeah.
A little Photoshop, boom, boom, done.
Yeah, if you want. Normally we don't need that part down here, so we are interested in all the rest for our measurements for our project. So what you get is those
got all
images.
your images.
Yes. So then we take those images into our FOVEX 360S, and that's the next step. I import those images.
Yes.
So here in this example, I only have 2.
Yes.
But I would have many more. I could import maybe 20 or 30 of them.
Yes.
And then process them together. We create a network.
So is there some relationship to it's going to do a space like this would take 10 rotations, that's 15 pictures, there's 150 pictures. From that 150 pictures, it's going to take a half hour to create a point cloud, an hour?
Exactly, so the parameters for the time, of course, is number of images, resolution, and secondly also the computer. So I'm using here just a normal laptop. So this took me maybe 15 minutes to process the entire project.
Yes.
If I use a desktop, a powerful desktop with a good graphics card, it would be much faster.
And now also I would imagine that I have a choice of the output of, is the word resolution? What resolution do I want on the point cloud?
So this point cloud you just saw, this was 25% resolution.
25% resolution.
It's already reduced.
So you could actually say, so it's a trade-off of how much time and processing and how big do I want the file to be that I need to manipulate.
Exactly, so for that, it's just a demo. Tomorrow we're going to do more examples here with customers. So we're going to use more stations, maybe 10 or 15, and we're going to process it at full resolution.
Full resolution. So let's go back to the big picture. This is a relatively new solution. Yes. And so what problem were you solving when you came out with this camera platform?
Well, first of all, I think it's a product which is more accessible. So in terms of price, we price is at $18,000 US.
So $18,000, pull it out of the box.
Yes.
And how much training do I need in order to be able to run?
It's very, very simple. So what you have just seen, I can sort the wizard here in 5 easy steps. I get to my point cloud. So this is really a simple process.
So if we're talking about $18,000 for this solution, I believe the problem or challenge you were solving was perhaps a laser scanner technology that maybe was priced out at $35,000 to $120,000, and by using the photogrammetry, you're able to apply a completely different approach to creating a point cloud.
I think it's complementary to laser scanners. It's not, of course, it'll never replace.
They'll never be as accurate, but for the price.
For the price, it gives a reasonable accuracy. So the 1 centimeter and 10 meters is reasonable for the gaming industry or for virtual effects or for rebuilding maybe a building. If you're not after a millimeter precision, that's fine. So, but this is the price tag we put into the product. This allows I think people who are having access maybe to laser scanning technology to get into the game.
All right, so let's see if we can sum up this new 4x, 3 times fast, 4x, 4x, 4 times faster, slower, 4vex,
FOVEX.
FOVEX, easy for you to say. So it sounds like the problems and challenges that your new solution solves, first, while not as precise as laser, it's far less costly for the solution.
That's true.
And second, in terms of operations, it does not require sending someone off to a class for a week in order to learn how to do laser scanning.
Yes.
And
We had really the people out in the field, for example, our police department in mind, the forensics people who do not engineers, who are not photographers. They want to be able to click on a button and let it go. And this is how we designed this product.
So this is great, Urs. I appreciate it. Now you hear it. It's press one button and you're done to create a point cloud. So I'm Dan Smigrod, founder of the Matterport User Group Forum here at IVRPA in Quebec City. And thank you again,
Thank you, Dan.
Urs. Much appreciated.
Thank you very much.